Okay, so I want to explain the exercise 10 in meeting 10. In the given question, the existing form, which means that you have to integrate with respect to y, it is complicated to be done. Okay, maybe you have a way to integrate, but not direct way. One of the way that it possible can be used, in terms of mathematical technique, is you can use the transform the sine y over y using the Taylor series or Maclaurin series. But in this case, that particular method is not in the discussion, which means that the point is, since we look at this one is quite complicated to be directly integrate with respect to y, so we want to change the order of integration, which means that we want to integrate sine y over y with respect to x, which means that sine y over y becomes a constant. So you can just have the x by hoping that after we integrate and substitute the limit that we will obtain on the next step, we have the simpler form in terms of y, so that we can integrate the new expression with respect to y easily. Okay, so that is the point that I want to focus in this exercise. Alright. So now how can you change the order? Yeah, you may see, when we say that change the order, we can just swap from dy dx to b dx dy. But for the limit itself, you cannot just give me or just write it down to be sine y over y, and you have dx and dy, and just swap the limit where you have x now inside and y is outside. So this is totally wrong. As I mentioned before, for definite integral, the solution, your final answer should be a number, a value. If you have this particular form, so your answer will be in terms of x. So it is not mathematically correct. So how can we overcome the problem, which means that we don't want our final solution is in expression of x or y. So the correct way is you have to of course change the order, but you have to make sure that the limit of y now, they are all constant, because now what become dy becomes the outer integral. Okay, the dy is now the outer integral. So meaning that you have to make sure before you proceed to integrate with respect to x first, you have to make sure that the limit belongs to y, they are all constant. But for x, it's okay, you can have both of them can be a function, or just one of them. One of the limit is a function. So how can you obtain the new limit? You need the region. Okay, you need the region. So how can you have the region? As I explained in the previous video, since you are given the information, the limit, the information about the limit for x and y, so you can make use this to obtain your region. So here, I rewrite into an interval form. So now x is from 0 to 2, and y is from x over 2 to 1. So now, as I mentioned before, we assume that just this one is just like an equation, 4 equations. So this one, x equal to 0, x equal to 2, y equal to 1, and y equal to x over 2. So since this one will give you a function, so I just rewrite into into an equation where you have y equal to x over 2, or you can have x equal to y. They are the same, just rearrangement only. Okay, so now from this equation, so you got 4 equations here, so we can obtain the region. Okay, so now based on the 4 lines, so among of these 4 lines, so x equal to 2y or y equal to x over 2, it is a function. Okay, so now now you want to know which you want to know the region, right? So which area need to be shaded. Okay, so whether sometimes it is a bit confusing. It can be the region over here, it can be region over here. So one of the way you can just list down all the 4 lines, but sometimes it is a bit confusing. So how can you overcome that problem? So how can you know that which area that you need to shade? So in this case, okay, so back to our order, the original question here. So you are given the dy dx, meaning the x constant. Remember about the vertical line and horizontal line that I told you before? So now in this case, you have x constant. So if it is x constant, you have to draw the so you have to draw the vertical line. Okay, which is this is the way how can you know your region. So you have to read from the question given. So from the question, it is shown that x constant. So then you sketch the vertical line, and now you read the limit. Okay, now you say that this is your line. So this line is for x. Okay, we're talking about x constant. So x from 0 to 2. Okay, 0 to 2. Okay, and then for the y is from the line of x equal to 2y, this one. So in this case, your starting point is that one, right? Okay, and then your end point is here. Right. So now we read for y. We read for y. So you just focus on the movement, your movement upward. Okay. So when you are walking along the y, okay, in that direction. So the first point that you met is belongs to the line of the green line here, which is x equal to 2y. And then you keep going upward, and the terminal point that you can have, which passing through the region, is y equal to 1, which is this point is belongs to the line of y equal to 1. So meaning that where is your region? So your region should be lying inside here. So that is your region. So you need to shade the area so that it will guide you the a correct limit. Okay, now you know from the information provided, and this is your region. Okay. So now once you done the finding the region from the information given, so it's time for you to find out the limit of x and the limit of y for your new order of integration. So in this case, your limit is no longer that one. Okay, but now your y is constant. So when your y is constant, now the line that you should draw should be what color? Okay, it should be vertical line because y constant. So now you can see the line in purple. So this line is lying between. So now y constant. So just look at the y. This is the smallest y, which is y equal to 0. And this is the highest one, y, which is 1. So y is from 0 to 1. Okay, now based on your region, so you can see that this is your, now you read for x. So you move along that way, along that direction. So your initial point here, it is belongs to x equal to 0. X equal to 0, and keep going to the right, and your terminal point belongs to the line of green color, which is x equal to y, x equal to y. So now you already obtained that your y is 0 to 1 and x 0 to y. And you can see here, by changing the order of integration, so now your y is constant. So that is the correct way. Okay, because we want to make sure that our final solution should be a number. Okay, and if you compare the limit here, are they the same? No, they are not the same, right? They are not the same. Okay, but still using the same region. Okay. Okay, so now based on this new order and also limit, so you can see that we have to solve for the inner integral. So which is we need to solve this first. So with respect to x, so these are all y, so sine y over y is constant. So when you integrate 1, just like 1 dx, so the answer is just x. So then you can have sine y over y still there. Then you have x, and then you only have to replace because the x is only here, right? There is no x inside here, so meaning that we just focus on substituting the value of x by using the lower bound and the upper bound that we have. So we know that x is from the limit here, so we can have x equal to 0 and x equal to 2y dy. Okay, so please don't forget to put the x or the y here, just to make sure that you don't substitute the incorrect variable, okay, the wrong variable. So it just very unlucky if you do that mistake. Okay, so then make sure that you write down like what I'm doing here. Okay, don't be so lazy. Okay, so now when you substitute sine y over y still there, then you have 2y minus 0 dy dy. Okay, and looks like we can simplify, right? So you have 2y, y cancel out, just 2 sine y dy, 0 to 1. So ask yourself, can we just directly integrate? Because the y over here are gone. Yes, of course, you can integrate sine. What is the integration of sine? Minus cos, right? Minus 2 cos. Y. Okay, and then replace the value of the limit, so 0 to 1. So for this case, you don't need to put y because there is only single variable, so of course this one belongs to y. So then minus 2 cos 1 minus cos 0. Cos 0 is 1. Okay, so now you have to be careful. You will get minus 2 cos 1 plus 2. Okay, you have to compute this. You cannot leave your answer in this form. Still incomplete. If you leave your answer, you give me the answer like this, so still you cannot get a full mark. So please evaluate this one. Okay, now how can you evaluate? That is my question. I have an interesting question here. 1 here is a number. Okay, so 1 is 1 here, you put radian, or 1 here you set as a degree. Which one? Because both of them will give you a different value. So the very important thing that you have to take note is 1 here is just a number, right? 0, 1 number. As long as they put this one 0, 0, and there is a degree, a symbol of degree, 0 degree, 1 degree, so that is very clearly it is a degree. But if it is just a number 0 to 1, pi to 1, they are just a number. So you have to make sure before you compute the cos 1, you have to set your calculator into a radian mode. Okay, so if you set your calculator in radian mode, your answer will be, okay, if you set in radian, and then after that you compute the cos 1, which is 1 here is in radian, so it will give you 0.5403. So normally just take 4 decimal places, okay, 4 decimal places. Okay, and then just compute this, so the answer will be 0.9194. But if you put this one, you forgot to change your mode, you just use the degree, then you have to check your calculator if you have D mean degree, if you have R mean radian. So then the answer will be different and that answer is wrong. So you have to be careful. Okay.